Hi, everybody. Welcome back to Chemistry 140. It's been quite a week. If you did not get the email yesterday, or text, or whatever it was that the college sent out, um, you should check your email. But mainly, all classes were canceled on Wednesday due to widespread power outages. I have no confidence that those power outages have been completely resolved in a day because there were a lot of them. But I did not get a notice today that said class was canceled, so here we are. What does that mean for us? So the Wednesday lab lecture, um, the lab is very straightforward. So if you've already downloaded that and started that, then great. I believe you should be able to see it. It should be posted. If it's not, let me know so I can fix that. But otherwise, there will be a short lecture that I am going to upload. I was going to do it yesterday. Then I recorded it, and I had this giant file that I had to upload that would take like 22 hours. So I spent the remainder of the day talking to the internet company and like, hey, what would it cost to upgrade my internet? And it turns out the cost would be very little. Uh, but they can't seem to physically do it because reasons? I don't know. Anyone who's ever been on the phone with the internet company knows like it's an ordeal. So I spent the afternoon talking to people trying to get better internet for my connection, thinking, oh, you could just push a button and now I have 300 megabit up and down instead of 2510. And no, that's apparently not what's going to happen. So that sort of screwed me up. So the new plan is now to just record them and stream to nobody, and then they'll appear on YouTube. That does mean that you'll get a notification later tonight or Friday or whatever when I do these. You can ignore that. I did send an announcement that has this information, so just in case you didn't get that announcement, that's what that's about. But we're here for today's lecture, so we're going to finish off Chapter 2, or Unit 2. I guess they're units in this class. We only have a little bit left to talk about in Unit 2, and that's just scientific notation. So, scientific notation is something that I'm sure nearly everybody in this class has seen at some point. I'm going to just give you a very brief primer of here's scientific notation in case you haven't seen it or used it much. It is a way to represent very, very, very large or very, very, very small numbers conveniently. And it also has one more benefit that we'll talk about in just a second. Now, what I've done here is this thing right here on the side. I don't have my pen selected. This right here is a multiplier. The value of this multiplier is currently 1, because anything to the 0 power is 1. And the value of the number over here is just whatever we're starting with. Are we doing the lab by following tomorrow's video? I will talk about the lab in the video, but for the most part, the lab is independent. Like, it is basically read this document, follow these directions, click on this link. Sorry, there's a leaf blower right outside my window because apparently this is the time to do that. Follow the link in the documentation and then answer a bunch of questions. I do require you to use Google Sheets, though, and if you don't know how to save your own copy and download, that'll be important to know from the video. And so that'll all be discussed in the video as well, and I'll show you how to do that. Here's our number. We're going to take our number and multiply it by this multiplier over here, which is just 1. But what we can do is I can move this decimal point this way and then change this multiplier. And for every step I move to the left, the multiplier will go up by 1. If I go in the other direction, I would reduce the multiplier by 1. And so let's see that in action here. So if I move this dot over all the way to the left, So it's just in front of that 1. I could do this. Do, 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 do. Ding. There you go. And then what I can do is I can then chop down however many digits I want or don't want based on how many significant figures I'm supposed to have, because having something in scientific notation means that it will nearly always invoke the decimal rule. So this gives us a way to write numbers to a specific number of sig figs that we normally could not do given how zeros work. So for example, if I wanted to write this number, 500,000, and I wanted to do 4 sig figs, that would be these 4 right here. I can't really do anything about 4 sig figs or 5 sig figs or 3 or 2 with this number, because if I put a dot after it, then all of them are significant, so that'd be 6, and if I don't do anything, that's 1. So anything between, I can't really do much about. So standard notation won't help us. But if I wanted to write 5 sig figs, I could do that times 10 to the 1, 2, 3, 4, 5. And this would have the same value, but have the precision of 4 sig figs as opposed to 1 or 6. The due date has not been posted yet. I will post that once I get the video up. So that's basically how scientific notation works. Is you move the decimal left, the exponent increases. You move the decimal right, the exponent decreases. You can then modify how many sig figs you write based on what you need. Okay? And then small numbers, same thing. I'll show the animation because it took me like 72 tries to get it right. There you go. I have some slides here that talk about, there's more examples. I have some slides that talk about addition and subtraction and multiplication and division of sig figs with, excuse me, with scientific notation. Not super important because you can do that on the calculator. And it's very difficult to actually type numbers into Canvas with scientific notation. There are ways to do it. When we come up to those, they will be mentioned in Canvas, like do this to type in scientific notation. But that's really all the time I want to spend on scientific notation, so I'm just going to scroll ahead to the end here. And I have this muted, so let me just do that so you get your little hooray. There you go. So that's the first 2 units of the class. The first quiz, which I will release today, I think I said I was supposed to do that last time, and I forgot. The first quiz is on units 1 and 2. Now, what that means for you is that I'm going to unlock a quiz, and an assignment will appear on Canvas for you to do. The deadline is a week from today, so it will be due... Sorry, that's the hard deadline. I'm going to set the soft deadline to a week from today, so it'll be due next Thursday. Then I will give you an extra day in case you need it, and then I will say last call for quizzes is tonight, turn it in, and it'll be due that night. So the deadline is Friday next week. You get a week to do quizzes in this class. I give you a lot of time because who knows what's going on in terms of timing. I know that I am not in a particularly better state now, a year into the pandemic, than I was early in the pandemic, so I assume that other people have shit going on too. And that you might need a few days to do a quiz, whatever. Your quizzes are a mixture of multiple choice, enter this number, etc. I don't reveal the answers or your score until all the quizzes are released, so once you take it, you'll just get a window that says, hey, the quiz is done, good job. You do get 2 attempts, and the reason for that is in case of weird things like, you know, the power failure yesterday, or Canvas blows up, or your computer crashes, or maybe you just don't feel like you did very well. The better of your 2 scores is what I keep for your quiz. You do not need to take both quizzes if you feel you did well on the first quiz. That said, I would recommend taking you both. Do I supply reviews? I give you all the worksheets online in these slides, but I don't give you a review worksheet. I give you enough material, believe it or not. I do tell you that the quiz is Unit 1 or Unit 2, so use these slides and the worksheet to go over what you think you need to know. Your screen's going to go... I don't know why that went off a second time. I hit escape, and for some reason it played the sound again. Your screen's going to go blank for a second while I set up the slides for Unit 3, because I have to open them from a folder. Those are labs. I want the slides. Alright, there we go. How many slides are in Unit 3? Oh, not that many. Okay, good. Oops. Alright, Unit 3 is very important, but probably not very long, I would say. The most important thing that we're going to do in this unit is right here in section 3.2. We're going to use a little bit of that in 3.1, so I'll just circle them both. This unit is the foundation for doing all of the mathematical analysis that you're going to do in Chemistry 140, 161, and beyond. Okay, this is how you convert units. For example, you probably know how to do inches to feet. You times it by a number, or you divide by a number, or whatever, right? Depending on which direction you're going. We're going to show the way that I want you to write that out so that you can do this every time with units, even the ones that you're not familiar with. Because we're going to start you with simple problems, and then I'm going to give you these ridiculous story problems that involve orcs on motorcycles riding down Interstate 5 through Seattle in 2074. And you're going to need to know how to solve these based on just finding the information that this is in the problem. And you're probably thinking to yourself, what the hell do Shadowrun characters have to do with chemistry? And the answer to that is I'm giving you crazy, weird units because when we get later on to converting molecules to moles and grams, those are essentially the same thing. They're crazy units that you need to be able to interpret and parse. So we're going to do all sorts of conversions, and I'm going to give you a variety of problems with a bunch of different dimensions to them. And your job will be to wade through all of that muck with the understanding that this is just exercise for Unit 11 and 12 later on, okay? All right, so let's talk about how we do calculations and measurements in chemistry and the other sciences. There is a system of units that you're probably familiar with, and it's called the imperial system. And the imperial system of units is stupid. The reason that this is stupid is because the numbers that are involved in all of these dimensions are rather random. So here are just a selection of these. What I'm going to try and do is I'm going to try and find this. Let me see here. Imperial system conversions. There is a picture that shows all of these, and I just want to find it to show you how ridiculous this is. There it is. I cannot believe how much shit is going on outside in my parking lot. Like, why is everything happening? I realize that I live in Everett, but still. Okay, so this is probably the best that I can get of it. But if I window capture window 4, and I go like this, so you can already tell that this is absurd. Yeah, I'd love to buy a house. I just can't afford it. There we go. So here are some conversions between imperial units here. And you can see that these numbers that are involved are absurd. So there are 1,760 yards in a mile. There are 3 feet in a yard. There are 6,080 feet in a nautical mile, which is also 10 cables or 100 fathoms. Or actually 1,000 fathoms. A fathom is the same as 15 shekels. Like, what the hell? Right? Like, who came up with these numbers? This is absurd. Did you know that a twip is on the micrometer scale? Like, what the hell? I didn't even know what half of these are. Or who measures in poppy seeds or barley corns? Like, no, just fuck off. This is stupid. No imperial units. Like, ugh. Like, that's the dumbest thing I've ever seen, right? And if you were going to be proficient with that system of units, you'd have to know all those numbers. And that's absurd. That's like 70,000 numbers. So what somebody did was they also told the imperial system to fuck off, and they were like, you know what, we're going to make this new system. I'm going to call it metric, and what we're going to do is we're going to make everything the same power. It's all going to be powers of 10 because our counting system is base 10. Why can't our measurement system be base 10? So let's do that. So these are some prefixes that are aligned with exponential multipliers. And so these are super convenient because now all we have to remember is the exponent and the prefix. So I can always associate milli with 10 to the minus 3. I can always associate kilo with 10 to the plus 3, and centi with 10 to the minus 2. So I don't need to remember all these barley, corn, and twip, and rod, and scrimp, or I don't know. I was trying to remember what the nautical mile one was. I don't have to remember any of those anymore. All I have to remember are these prefixes, and then I can apply these prefixes to anything. That picture that I showed you, this is just length. There's one of these for mass, and the one for volume, and it's just like, why? But milli, kilo, and centi, these will apply to any dimension that we want. So we could do kilogram or kilometer. It's the same thing. It's going to be 1,000 of whatever the unit is that we're talking about. So this is super convenient. So this is the system that we're going to use. We are not going to do anything with imperial units other than convert away from them. So I might give you a distance in miles and say, like, how many kilometers is that? Then yeah. Or I might have you go in the other direction just for practice. But in the laboratory, any empirical units that we have, including Fahrenheit, we're going to convert to metric units. For our purposes, Fahrenheit is an imperial unit, and Celsius is a metric unit. Even though you won't really see millicelsius, because why? For our conversions in this class, you will want to memorize the metric system. I think my pad is turned a little bit. Hold on. Erase. Trying to draw on a straight line. I'm also just bad at drawing straight lines. There we go. You're going to want to memorize the metric system of units. But the imperial metric conversions are not worth memorizing. You can always look them up on, charts like this. Shackle, that's what it was called. Not a shmup or whatever. All right. Now, on the screen, I'm going to put a bunch of units for length. Those are all different units for length that are used in various capacities. I think my favorite one here is the smoot. The smoot is the height of an MIT civil engineering professor and is specifically used for measuring bridges. They measure it in how tall their instructor was units. So like a bridge might be 13 smoots tall because their instructor was 5 foot 10 and a half or something. I don't know. It's something like that. But that is a unit that exists. Is it in widespread use? No. Do we give a shit about it? No. But it exists. And so we need to choose one of these as our standard. And so what we're going to do is we're going to elect for each dimension a specific unit that we are going to employ as our base. And the base unit that we've chosen for length specifically is the meter. These units are called SI units, or Système International d'Units, if you are a haughty French person. You can interpret hottie as however you want to. I am intending Haughy, but if you want to go with Hotty, that is fine too. I'm French Canadian, so I'm allowed to insult my own people. My mother is from Quebec, Montreal specifically. Um, yeah, so SI units are going to be the specific units that we use um, in this class, and we have elected a specific unit for each dimension. So for length, we're going to use meters. So that's the first one we got here. For the other ones, and I'm going to put 5 of them on the screen here total. These are the 5 units or dimensions that we're going to care about in this class. We got length, we got mass. Mass we're going to measure in grams. I'm going to talk a little bit about the kilogram in just a second. Time is going to be measured in seconds. Temperature we're going to measure in Kelvin. You might not have heard of Kelvin. We'll get to that in Unit 5, though. And then quantity we're going to measure in moles. Moles is kind of the weird new unit, which we're going to introduce in Unit... I want to say like 10 or 11. It's later on in the class. Now, specifically for mass, the SI unit is the kilogram, but only because the kilogram represents a more useful unit for most professions. So, for example, a physicist who is trying to figure out how much weight they can hang on a pendulum that hangs off of a bridge or something and might be hung to like a beam that is load bearing. Using kilograms is far more useful than grams, for example, because grams would be you just get a ginormous number. For us in the chemistry lab, though, when we do our experiments, we don't want to work with kilograms because that's just too much. If you did a reaction with a kilogram of reactants, your flask would just be giant. You'd have to do like liter-sized experiments, and we can get the same thing by scaling down a lot. So we use grams, and sometimes we just use milligrams. So the other units are pretty straightforward. We'll come up to those as we get to them. Very important to note that these units all are independent of one another, and you cannot convert one unit to another without a different sort of intermediary, we'll call. So, like, if I wanted to turn meters into seconds, I can't do that normally. Because seconds isn't a length, right? Neither is meters a time. But if I relate the two together using something called a velocity, I could figure out in how many meters I go per how many seconds. So there are ways to convert between these units, but not directly. You have to use a relationship. And a relationship exists for most of these. All right. So these units that we showed on the previous slide, these are our base units. And I'm not going to highlight the kilogram there. I'm just going to highlight the gram there. And what we're going to do is we are going to modify these values so that they represent a quantity that we may wish to work with. For example, if I am measuring the distance around our planet, we're going on the longest road trip. We're just going to drive straight around the equator on our hover car or whatever. You don't want to measure that in meters. That would take a long time. Even kilometers might take a long time too, and give you a very large number. So we can put a prefix in front of that to change its value so that we have more reasonable numbers to work with. For example, a megameter might be more appropriate because going around the planet, you might hit like, I don't know, 2 of those or 3 of those or something like that. Oh my goodness. If it wasn't one distraction, it's another. Yes, what do you want? Yes, okay. Someone wants to say hi. Come here. Come here. Come here. Say hi to the class. Say hi. Hi. Hi, will you stop hugging me now? It's our daily Maya visit. She has come to say hi. She wants to jump on my lap, but I have to actually lecture. Let me just put this on the screen here, and you can copy it down or look it up however you want to. I will pick up the cat. Oh no. She got caught on a cord, and everything started moving around. There we go. There we go. Now I have a cat on my lap. Um, so on this slide, what I want you to do is I want you to have this slide handy whenever you do calculations, or just commit these to memory. Because you are going to be using these prefixes so often that it becomes worth it. Now, specifically, I got to reach over the cat to do this. Watch out. You're going to use kilo. You're not going to use hecta. What am I saying? Yes, hi. You're going to use that one a lot. You're going to use this one a lot. You're going to use this one a lot. Actually, you're going to use all of these a lot. Oh, oops, sorry. Maya, don't jump down. Sorry, it's very hard to draw a straight line with a cat on your lap. You're going to use all of these all the time. And then mega and giga are pretty important too. I didn't highlight the whole thing for kilo, but that's okay. There you go. So if you had to like hedge your bets and choose some to memorize to make things convenient for you, I would pick those. The other ones are not as common. Like Terra is useful for like hard drive sizes. Okay, she's happy. No, don't rub against that. Now she wants to go rub against the power outlet, which would make my stream go down. Hi, yes, I did just pet you. She's just gonna sit there and chirp at me. So Terra is important for like hard drives and stuff, but we're probably not gonna look at Terra meters. Uh, Giga and Mega are also hard drive sizes, but those will come up. Okay, Maya, stop it. I can hear her through my headset. Okay. These slides just talk a little bit about these units. So, I mean, you all know what a meter is, I'm sure. We're going to use the centimeter and the millimeter much more often when measuring smaller objects. And then when we look at things like bond distances or how big an atom is, we use nanometers and picometers. So that will come up more in 161 when we talk about wavelengths of light and things like that. But for now, just be familiar with these different prefixes and approximately what they represent. The whole point of this discussion is not just for me to pet my cat, who did just leave, thankfully, but to try and associate a given unit and its multiplier with something that you could hold on to. So, like a meter would be half a person in length, whereas a centimeter would be like, I was gonna say a paperclip, but a paperclip would be several centimeters. So, like if you did the little like pinching noise, that would, or not pinching noise, pinching motion with your fingers, that would be a centimeter. So let me see here if I can. There we go. That's the one I want. No, that's not what I want. So if you do this with your fingers, the distance between them would be a centimeter, and so on. We've already talked about mass and weight. We don't really care too much about the kilogram. We're going to use regular grams for stuff in this class. But for practice problems and stuff like that, you're going to see kilograms quite often just because it is a more useful mass to represent something in. If I give you the mass of like a bowling ball, giving it in grams is not terribly helpful. Likewise, giving the mass of a car in grams is not very helpful either. But kilograms are a good all-purpose unit. Volume's kind of a special unit. And the reason that volume is special is because it's not SI. There is no SI unit for volume. Specifically speaking, that we need to construct volume from SI units such as length. So if the SI unit of volume is, or I'm sorry, if the SI unit of length is a meter, and volume is just 3 lengths multiplied together, then the SI unit should be cubic meters. But a cubic meter is a very large unit. You could put about 1,000 1-liter bottles of water, or 500 2-liter bottles, in a cubic meter to fill it up, assuming that that liquid was water. And that's a large amount of volume. I don't want to work with something like that. So what we're going to do is, first of all, this is called a derived unit because I had to derive it from meters. But secondly of all, what we're going to do is we're going to choose a more convenient unit to use in chemistry. And that unit that we're going to use is the liter. Area is also a derived unit because it's just two lengths multiplied together. In this class, anytime you need a formula for an area or a volume, you could just look it up. I try to provide them. We're not really going to use those volume or area formulas that often, but they may come up in later calculations for specific problems like a platinum sphere is made of this many atoms, what would its radius be, or something like that. And you can actually solve that. You'll be able to do that by the end of the quarter. This is a much more convenient unit of volume. This is the liter. A liter is a 1 by 1 by 1 decimeter cube. A decimeter is just 10 centimeters. So if I multiply 10 centimeters cubed, I get 1,000 cubic centimeters, which means that 1 liter is 1,000 cubic centimeters. Or, and this is actually really convenient for us, if I convert this to milliliters, there are 1,000 milliliters in a liter, so I can divide both by 1,000 to get milliliters. I then get this relationship. 1 milliliter is 1 cubic centimeter. That's actually going to be very useful. Keep that definition in your back pocket, because there will be times where you have a volume in milliliters and also in cubic centimeters, and you might be like, how the heck do I get from one to the other? And if you forget this relationship, you're just kind of stuck. But they are exactly the same thing. So if you see the abbreviation cubic centimeter or cc, that's just milliliters. Okay, those are all the units that we're going to work with. So let's actually do some work with them. We're going to start with simple conversions, and then by the end of the period, we will be doing more complex ones. This is a short unit, but we are going to take these nice and slow because I'm going to give you time to do practice problems. And I want your work to look like mine. I want you to show all of the unit cancellation. This is really important. So a lot of the time in these types of classes where I'm teaching how to do dimensional analysis, I hear from students, oh, I was taught this way. Can I do it this way? The answer is always no. Okay. So right now, what I want you to do is any way that you've learned to do dimensional analysis or units, forget it. I know that's a tall order, but what I want you to do is specifically learn to do it this way, because this is what scientists do. Okay, I am not training you to do dimensional analysis how I do it because that's how I do it. Like, I don't give a shit if you do it my way or not, but I do give a shit that you do it in a way that you can communicate this information effectively to other people. And because I know other instructors expect you to do this, not just in chemistry, but in engineering, I really, really, really want you to focus on doing the dimensional analysis in this manner. Okay? So don't do other methods. What those methods are, I'm not going to say because I don't even want to mention like cross multiplication or anything like that and show it, because then people will just do that. Don't do it. Do it this way. Okay? All right. So the first thing that we're going to do is we're going to establish some truths that we have created by establishing these metric definitions. So, for example, we said that this is true. This is a definition. We're going to define 1 centimeter as 10 to the minus 2 meters. We're going to define 1 millimeter as 10 to the minus 3 meters, and a kilometer is 10 to the 3 meters. All of those definitions are on that giant table that I was highlighting when there was a cat on my lap. If you want to go review that and hear the cat meowing, you can just scroll back in the video. It'll still be there. Maybe Maya will come back later in the period. Who knows? But what we're going to do is we're going to make relationships out of these terms, and I'm going to show how you do that on this slide here. Or not this slide, but on the sample previewer. So what I'm going to do, I'm going to pick one of these, and I'm just going to pick kilometer because I don't know reasons. I'm just going to pick it. So I'm going to start with the conversion as written. And then what I'm going to do is I'm going to divide both sides by the same thing. And that same thing is going to be just everything on the left side. Now, when I do that, I get an interesting situation on the left. 1 divided by 1 is 1, no big deal. But what happens when I divide something by itself? Even if it's a unit, like 4 divided by 4, or kilometers divided by kilometers, or Maya divided by Maya. Oh, she didn't hear that. That's good. Whenever you divide something by itself, what do you get? You get 1. It all cancels out, right? So this kilometers divided by this kilometers cancels out. And so the result on the left side of this problem would be 1. On the right side, I don't have anything that cancels out. I have 10 to the 3 meters over a kilometer. Okay. Now, that on its own is not interesting. But what we're going to do now is I'm going to do the same thing again. And now this time I'm going to divide by the other side. And the same thing happens. Meters divided by meters is 1. 10 to the third is 1,000. Divided by 10 to the third, which is 1,000. That's also 1, so those cancel out too. And on this side, I get 1 equals this term. Now, if something equals 1 and something else equals 1, what must be true about the two somethings? Yeah, they have to be equal to each other. They're the same thing, right? So there we go. We have now proven that these two terms are identical. Now, why is this important? This is important because I started with this statement, which was a definition. I then turned it into these two things, and then showed that they are equal to each other. So what you can do is you can take a horizontal relationship and turn it into a vertical one, and you can put the units in whatever order you want to, as long as the numbers show up in the right spot. So this 10 to the 3 needs to always show up with the meters. And the 1 and the kilometers would always be in the same side when writing this definition. Okay? Now, why do we care about this? Why would we want to put up vertical relationships? And the answer to that is because when we come down here and I say, okay, I have a bowling ball that weighs this many kilograms. How many grams does it weigh? You could then say, oh, well, I know that in a kilogram there are 10 to the 3 grams. So I'm going to then set up my relationships like so. And then you can select the relationship that you want. That makes the units cancel out. So if I used this relationship here, then I could say, oh, well, look, I have kilograms divided by, that's the wrong button. I have kilograms divided by kilograms. And so those units would go away. And then when I solve this, I have 5 times 10 to the third grams, or 5,000 grams. And so when you look at that unit, let me do... Oh, that's the button I want. When you look at the problem like that, that's probably the calculation that you expected. Oh, I know how many grams are in a kilogram. It's just that times 1,000, right? But you can see that by making these relationships up here, or here, I now have 2 conversions that I can use to cancel out units, okay? This act of canceling out units and figuring out what a value is in a different unit is called dimensional analysis. Okay? Dimensional analysis is the language that scientists speak when it comes to doing calculations. And so what you're going to do is you're going to first figure out your conversions. So that's these guys. And you don't have to do the proof, obviously. You're just going to look it up in a table or use it from memory and then write down a conversion that you need. And then secondly, you're going to string conversions together until your units cancel out to give you the thing that you need. The beauty of dimensional analysis is that as long as you have the units set up correctly and they cancel out, and you put the numbers in the right spots with the right units, which is easy to do, like 10 to the 3 will always go with grams, for example, with this conversion. As long as you set that all up correctly, you can never get the wrong answer. It will always be the correct answer. Now, of course, semantics, you might type it in the calculator wrong, but you will at least get very close to the right answer. All right, so now that we know how to do these conversions, so I'm showing how these are done on millimeters to meters, we can make these relationships to prepare us for dimensional analysis. And so that's what we're going to do. We are going to now use these conversions in dimensional analysis. We're going to start with simple conversions, and then we'll move to more complex ones. Now, if you are trying to create conversion factors from memory, using the table that I showed you before, let me find where that table is. It is on slide 6. So, unfortunately, I can't scroll out. I guess that's not a feature on this. Let me go back here. So if you are using these conversions and you're trying to remember them from this table, that could be kind of difficult. You might associate, oh, here's a number and a prefix. What is the relationship that I do there? Well, the rule is that if I ever... So I'm going to do megagrams here. So megagram and how many grams? The rule is that both sides have to equal the same, right? Because it's an equality. So I'm going to need something that is worth 1,000,000 on both sides. So if I do this, I have 2 things that are worth 1,000,000 right here. So this is worth 1,000,000, this capital M, and then this is worth 1,000,000. You need to put the prefix and the number on opposite sides. Yeah, what the hell is a megagram? I don't know. It's 1,000 kilograms. Actually, a megagram would be a metric ton. Now that I think about it. So this is a metric ton, but we could call it megagram. Okay. So you need to have the prefix and the number on opposite sides. If you put the number and the prefix on the same side, then you have 1 equals your giant-ass number, very tiny number, times itself. And that's not going to work out. Okay, so remember, you got to make it an equality. So put the number and the prefix on opposite sides. The other thing that I like to do, and I'm going to have to clear the screen here for a second so I can go back to that slide that we're on. The other thing I like to do is that if I have a prefix, oops, I didn't realize it would take my pen away. If I have a prefix, I always put 1 next to it. And I call this B1 with the prefix. Kind of like you're doing some sort of like Star Wars yoga. Not Yoda, but yoga. Maybe it's Yoda doing yoga. And so you put your hands together and it's like, take a deep breath and raise your shoulders until they reach into the sky. Stretch your arms until they pass through the walls. Be one with the universe. Be one with the prefix. Ah. That sort of like crazy crap, right? And then the number goes on the other side. So whichever way helps you, be one with the prefix, where you put the 1 and the prefix on the same side, or just put the number and the prefix on opposite sides, the number from the table. Whichever way you want to commit to memory that helps you, do that, okay? I just want to give a bunch of different ways. Everybody has their own different preferences. On this screen here, I have metric to imperial conversions. These numbers do not have any sort of basis in a table that is simple to remember. So you're going to have to look up these conversions that have been measured already for you. Okay. The easiest way to do this is Google. For example, if you type in meters to inches, Google will give you this conversion. Where'd my cursor go? There it is. If you type in liters to gallons, Google will give you this conversion. Now, there are actually 2 conversions for these. So, for example, I gotta punch this in my calculator to do that really quickly. You might also see this conversion. And these are equivalent. How did I get from one to the other? Well, what I did was I took 1 divided by 39.37, so I moved where the 1 was. Either of these conversions will work because they have the same value. All I've done is do the math here. And so you will see different versions where you have the 1 on the top or the 1 on the bottom, and then the other unit is different. Both of them work. So if you see, like, for example, 453.6 grams per pound, there's another one for that. That's for kilograms, though. So 2.204 pounds per kilogram, or 0.4536 kilograms per pound. Like, there's going to be different conversions depending on which unit has the 1 in front of it. So if you see numbers that look different than what you're familiar with, don't freak out about that, because they exist. The other thing I want to comment on is that for a relationship like this, we called this a definition earlier. How many sig figs are in a definition? If you define a term to be true, how many sig figs are available? Well, if there's only one, that'd be kind of a bad definition, right? Because we said that one sig fig was not very precise, and that more sig figs would be more precise. When you define something, how much error is there associated with it? So, like, I've defined that there are 1,000 grams in a kilogram. Is that exactly 1,000? Almost 1,000, plus or minus? Not quite. What did we say that definitions were the other day when we were talking about exact and inexact? There you go, infinite. Why is it infinite number of sig figs? Because definitions are exact. They're exact numbers, and therefore have infinite sig figs. So metric to metric conversions are all definitions, and so they are all exact and have infinite sig figs. These up here are not metric to metric. These are metric to imperial. And when they are written like this, they are approximate. And so what that means is that the number of sig figs is shown in each value. Now, you may actually see a situation that looks like this. And so what I'm going to do is I'm going to blank this out. And then I'm going to write over it. So we'll just do this. So you might see something that looks like this for a conversion, where they put just 1 by itself. And the temptation to look at that and go, oh, there's only 1 digit there. How many sig figs is that? It's really easy to say 1. Whenever you see 1, whenever you see that 1 there by itself, it's implied to be exact. So what that means is in exactly 1 meter, there are, and then down here, this is always approximate. In exactly 1 meter, there are approximately 39.37 inches. And that approximation is good to 4 sig figs. The reason that we have an exact value and an approximation is because for our meter, we're going to put a little dash down on the meter stick, and that wherever that dash is exactly a meter. But our object that lines up against that, which might be the inches stick, if I put my meter stick next to the inches measuring stick, it's not going to fall exactly on a line. And even if it did, we'd be measuring. We'd still have to approximate based on how many marks are there. So whenever you see... Oh, excuse me, hold on. Oh, got hit with the yawns there. Whenever you see a conversion and one of the numbers is just 1 by itself, don't ever use that to worry about sig figs, because that's intending to be exactly one of these things. The other number will always be the approximation. So in exactly 1 gallon, there are about 3.785 liters. And in exactly 1 pound, there are about 453.6 grams. So that's where we're coming from with all these conversions between imperial and metric. And again, you can get all these numbers off of the internet. So there's our summary for that slide. Metric to imperial are always approximations with very few exceptions. There is one specific one, inches to centimeters. That's a definition because we defined inches based off of that. But anything else that goes imperial to metric will be an approximation and will have a number of sig figs in its value based on what conversion we acquire. But whenever we do metric to metric conversions, all of those conversions are definitions. We've counted them and said this is true. And therefore, whenever we apply them to calculations, they won't affect our calculations number of sig figs. Why do we care about that? Because whenever we're doing these conversions, we have to care about the quality of the measurements that we have. If I have a very, very precise measurement of like 7.4286915 liters, and I want to turn that into gallons, if I want to keep all those sig figs, I need more digits than just these 4. Otherwise, that would limit my precision. All right, so what we're going to do, I think it's time for break, yeah. Once we get back from the break, we are going to go over dimensional analysis problems like that one with a bowling ball. In fact, I think the bowling ball problem comes up in just a second. But for now, we're going to take, that's not take a break. There we go, that's take a break. For now, we're going to take a break. Go and get more water. I certainly need more water. Go and pet a cat. Let me get the clock on the screen. There's the clock. Where is my music? There it is. So we'll do this, and we will play the last little bit of Paradise Killer music that we have for the week. So see you in a bit. All right. Welcome back. Hope that you were able to get a drink, pet a cat, etc. That's the wrong slide. There we go. I went and pet the other cat. I have two cats. You probably will never hear Kresnik because he only yowls from the hallway. He'd have to be really loud, and I don't know if my mic can do that. Alright, so before, when we were showing how to create those conversions, we put a bunch of units one on top of another after we did division, and then we canceled some of them out. Any units that appear on both sides of a division line will get canceled out and go away, leaving just the units that remain. The whole premise behind dimensional analysis is to set up our units such that we get rid of the ones that we don't want, and we leave only the ones that we do. So in order to do that, we're going to have to kind of blueprint our way through a problem and say, okay, I'm starting with this unit. What can I turn that into? What can I turn that next unit into? And so on and so forth. And then we can eventually get to the unit that we desire based on what the problem that we're trying to solve is asking. Okay? So let's do a really basic example. We're going to convert meters to inches, and I'm going to do it two ways. I'm going to try and do it in one step, and then I'm going to try and do it in multiple steps. I'm clicking in the wrong thing. There we go. That's not going to work. There we go. So what we're going to do, let's clear all this stuff out. What we're going to do is we're going to start by going directly from meters to inches. Now, whenever I do a problem like this, what I try and do is I set up these little, like, nodes of a flowchart. Kind of like that awful image of the the imperial units that we saw earlier, where there were a bunch of arrows connecting all of them together. I'm going to do a much smaller version of that, but I'm going to only use the units that I care about, okay? And then what I'm going to do is I'm going to go look up the conversion for the units that I want to. This one happened to be on a previous slide, so I'm just going to go back and copy it from there. So 1 meter is equal to 39.37 inches. And so I'm going to write that like this. This is my setup phase. Once I've finished with the setup phase, what I'm then going to do is I'm going to take the number that I was given and write it down. And now I need to convert it from meters, which we started with, to inches. In order to do that, I need to cancel out the meters unit and end up with the units of inches. So, how do I do this? What unit should go on the bottom here to cancel out this right here? Well, they got a match, right? And then I will put the other unit that I had. So I've now exchanged meters for inches. I just need to go fill in the numbers. I have 1 meter, so I'm going to put this number right there. 39.37 inches. We're going to put this right there. If the only unit that's left in the problem is the unit that you want, then now what you do is you just do all of the multiplication or division or whatever. So since this is the unit I want, this is the unit that's going to be left over, I can then put this in the calculator as shown. 1.52 times 39.37. And the answer that comes out of the calculator is 59.8424. The last step is to consider sig figs. So how many sig figs should my answer have? That's going to depend on what numbers I used in this multiplication, right? So this number right here had 3 sig figs. This number here has 4 sig figs. That should be an F there. You can't really tell. And this number right here is exact because it's just the 1 by itself. So this is infinite sig figs. So what's the least number? 3, 4, or infinite? It's 3. And so this is the answer I would report. once I actually write my number well. There we go. All right, that was how to do it in one step because we have that conversion available. We know how to get from meters to inches. Let's suppose that we didn't have that conversion and instead we were trying to think of our own conversions to get from meters to inches. And so a potential conversion that you could do would be, well, I know how many meters there are in a centimeter, and I know how many centimeters there are in an inch. I can go look up these conversions. So this first one here is just a metric to metric conversion. 1 centimeter is equal to 10 to the minus 2 meters. Because that was the number on the table for centi. And then if I want to look up centimeters to inches, I can look up this one. 1 inch is equal to 2.540 centimeters. So now we're going to solve the same problem. But we're going to take a different route to get there. I'm going to turn first meters into centimeters. So again, I got to cancel out the meters. We'll put the centimeters up here. And then I enter in the numbers as shown. 1 centimeter, 10 to the minus 2 meters. Just match them up. This isn't the unit that I want to end with, though. So if I hit enter, I just get centimeters here. I want to get to inches. So I'm going to keep going. I'm going to put centimeters down here to get to inches, because then those would cancel out, leaving me with inches. And then I fill in the numbers again. This is the unit that I want. It's the only unit that's left, so this will give me the answer. And when you punch this in the calculator, even though it looks totally different, you find that you get the same answer. At least as far as rounding is concerned. I'm even going to scroll up to show you that. So I got a 5 down here in the last position, but remember, we only care about however many numbers we're going to keep for sig figs. So this is exact. And then this is 4 sig figs. This is actually exact, but I'm just going to write 4 for you. So no matter which route you take to get there, as long as you are using your dimensional analysis with correct conversions, and then putting those conversions in the right spot, you always get the same answer. We have set up dimensional analysis to be like that. All right. Any questions on what we just did? Because we did the same problem twice in 2 different ways. We got the same result 2 different times. All right, that's a really simple example. We're going to be working with much more difficult examples. So let's try some more difficult problems. This is a more basic one, but I want you to try it just to get the hang of this. So you're going to have to look up the conversion from kilograms to pounds. So this is my Harley. I own a Harley Davidson. I almost said Scorpion because I play Shadowrun. Harley Davidson Sportster. I'm thinking of selling it. I'd like a larger bike, but I don't really ride right now because it's winter. What is the mass of my motorcycle in kilograms if it weighs 625 pounds? Do this with dimensional analysis on paper. Don't just type it into Google. because I want you to do the practice, okay? So once you get the answer, type the answer into the chat, and we'll go over the answer together in a second. Once you have the answer, type it in the chat for me, just so I know that we're all done. One more minute to finish your problem up. Finalize your answer. All right. Oops, I've captured the old problem. I want to do the new one. All right, there we go. So we're going to do the same thing. First, we're going to blueprint out our answer. So I got kilograms, and I know a conversion that will turn that into pounds. And so that conversion is 1 kilogram equals 2.204 pounds. Now, in order to get that conversion, you have to look it up on Google or in your textbook or another source. You could also do kilograms to grams to pounds if you'd like. I just happen to have this conversion handy. That's the wrong side of the pen. Like, where is my cursor? All right, how many pounds do I have? I have... Oh, I'm going the other direction. Ha ha ha. I'm doing the wrong problem. So, really, what we're doing is this. We started there instead. That's okay. All right, so I got pounds. I'm going to turn pounds like this to cancel them out into kilograms. And then that's the unit that I want to, so we'll write that down. Let's fill in the numbers. 1 kilogram, boop, 2.204 pounds. We'll punch it in the calculator. I got 283.575. That's more than enough digits. How many sig figs should my answer have? Well, this right here has 4. This is exact. And this has 3. My answer should have 3. So that's how much my Harley weighs. Yes, I have had to pick it up when it's been dropped, because when I started driving, I would drop my Harley all the time, which is never fun to scratch up your new ride. It's a very old motorcycle. It's 10 years old. It has over 70,000 miles on it. It's time for a new motorcycle, but I'm just about to pay off my Jeep, and I don't want to be in debt again, so you know. C'est la vie. All right, so my answer matches up with the answer that everybody else got, so that means we must have all done it correctly. Good job. All right, so let's give you more problems to do. So I'm going to give you 5 problems here, and I'm going to give you some different units. So someone was asking me about orcs in the Discord chat, so here's another orc problem. The story behind this is that I used to play World of Warcraft a lot, and so I made all my problems orc-themed just because people were also playing it at the time, and my students thought that was cool. Now it's just my little shtick that I stick to. Also, orcs are fun. I play them in D&D, and it's great. Let's assume one weighs 145 kilograms. Would that mass be in grams, milligrams, and pounds? For each of these, you're going to get progressively larger and larger numbers, so these are going to be really big numbers. And then down here, I live about 16.1 miles away from Everett Community College. I want you to tell me that distance in furlongs, because I want to take a horse there, I guess. I don't know. Furlongs are used in like horse races, and that's all I know. And then tell me that distance, 16.1 miles in centimeters. Okay. So I'm going to give you like 8 minutes to do this, because these aren't difficult, but when you're learning, they take time. So set up the little blueprint, then set up your units, enter the numbers, and then do the arithmetic for each problem. Type in your answers once you get them. I will do something like this. So we'll go A, B, C, D, E. So you know which problem to assign to what. So you can go A is this, B is whatever. Okay? Try these, type in your answers as you get them. We'll go over the answers together, and that might be all the time that we have, because, well, I can't see this taking 30 minutes, but probably spend 15 minutes on this part. So go ahead and do these practice problems. So I'll be right back. She wants to be hugged. I'm gonna pet the cat. You guys keep working. How are we doing? If you have any questions about these, let me know in the chat. I see some people are starting to put their answers in. I went and put Mai on the cat tree. I don't know if she's going to stay there. Let's do 3 more minutes, and we'll go over the answers for these, because I see some answers coming in. All right, let's go over the answers. If you don't round to the same exact numbers as me in the labs or quizzes or tests, I generally allow a small amount of error. So remember, the whole point of sig figs is that the last digit is the uncertain but estimated digit. And so as long as you were within that range of my estimate, then you're fine. Generally speaking, that means that you have to get all the digits right, but the last one you can be plus or minus 2 or 3. And if you are close enough to that, then I give you full credit for it. If you're further off than that, then that means that you've either made a calculation error or you set up the problem wrong. Let's go like this. We'll just put all 3 of these together up there. All right, delete. All right. Gotta find my stylus here. All right, so what we're gonna do is we're gonna start by blueprinting our units. So I'm gonna, oh, I have the wrong color. There we go. So we start with kilograms. And I want to go to grams first. And I know that in a kilogram, there are 1,000 grams. Maya, I literally just petted you. She says, I know, but I want to be pet again. I'm glad that you guys like my cat. Alright, so I've set up my units so that I get the units that I want. Now I gotta do the conversion, so 1 kilogram is 1,000 grams. And now I just do the multiplication. Or I could do this. 3, 4, 5. Either of these is fine, because they both have 3 sig figs. So you could enter either. Now what I want to do is I wanted to get the answer in milligrams. So I could start the problem over. Or what I could do is I could just do this part. I could say, well, I know what the answer is in grams. I'll just turn it into milligrams. Do it in one step, right? My cats are so spoiled. Like, I let them free feed because they aren't overweight. When I got Maya, she was like 14 pounds. She was very overweight. The joke with that was that Maya was my bowling ball. I was bowling at the time because, not a pandemic. This was like 2018 when I adopted her. And I actually could do that test. I have a 14-pound bowling ball that I use. And I had Maya, and I would lift them both one at a time, and I couldn't really tell the difference. But I changed what food I gave them, and she lost a lot of weight over 2 years. So now she weighs like 9 pounds or 10 pounds, and she feels so light. She's a lot happier now. Let's see here. Where am I going? I got to use the answer that I have from the previous problem. So we'll take this. So this is just this number right here. We're going to just use it again. And then we're going to convert grams to milligrams using this conversion. So 1 milligram. Oops, I didn't cancel here. 10 to the minus 3 grams. That's not going to be enough space. Hold on. I pushed the wrong button. There we go. And so this will be 10 to the 5 divided by 10 to the minus 3 is 10 to the 8. So that'll be that. Which looks like what people typed in there. And then finally, I need to get this answer in pounds. And I could do that from any of these points, or I could just start at the beginning. And I actually think that starting at the beginning is easier. So if I do this as my blueprint here. Then I can just go back to 145 kilograms. Do kilograms to pounds to cancel my units. And then I just fill in the numbers. So 1, 2.204. That I need my calculator for. 145, 2.204. 319.58. That's going to round to 3 sig figs. 320 pounds. So important to have that dot in there because we want to make sure that we represent that that is 3 sig figs because these had 3 sig figs over here. This was 4. All right, those are the first two. Let's do the next two. Oops, that's not scrolling. There we go. So I live 16.1 miles away from work, according to Google Maps. I want to find that distance in furlongs, so we'll do miles, and then I'm going to go like this. And then we're going to go this way to get to centimeters later. A furlong is 1/8 of a mile. And I've only ever seen furlongs used in horse racing, so... We got our units set up so we can cancel them out. That means our answer will be represented in furlongs, so let's enter the numbers in. So 1 furlong is 0.125 miles. And I get 128.8, which rounds to 3 sig figs, 129 furlongs. So this is 3 sig figs. This is actually exact, but you didn't actually know that. That's okay. This will be 3 sig figs. If the correct answer is 3 sig figs, but you put in 4 sig figs, it would get marked wrong. So you need to only have 3 sig figs. Now, Canvas actually doesn't know that. So on Canvas, it would be okay. But in an in-person class, if I was grading your paper, I would put sig figs on your paper and deduct a point. So I am giving my instruction as if this were an in-person class. But I realize that Canvas doesn't know what sig figs are. And in fact, on Canvas, what I do is I tell you, enter your answer to 3 sig figs, and then I give you all your numbers to 3 sig figs, and then it's just not an issue. The problem with using more or fewer sig figs is that if you fall outside of my rounding limit, Canvas will mark it wrong. So if you're outside of like plus or minus X in the last digit that I expect for 3 sig figs, it'll be incorrect. Generally speaking, if you put more sig figs, that's not an issue. But if you put fewer, it very well may be. All right, what is this distance in centimeters? So for miles, I can go from miles to feet, and then I can go from feet to inches, and then inches to centimeters. That's one way to do the problem. Another way to do the problem would be to do miles to, I don't know, we'll say kilometers, and then meters, and then centimeters. Any of these directions will work. Because you get to the same unit, you'll just enter different numbers. We're going to do... Let's do the top path, because I know these metric ones. So I'm just going to say there's this many meters in a kilometer, so that's that one. And then there's 10 to the minus 2 meters in a centimeter. And then I just have to look up miles to kilometers, and I forget what that is. I think it's like 1.609. So we'll go to Google. 1 mile to kilometers. Yeah, 1.6093 kilometers. Okay, so We'll start with our distance, which was 16.1 miles. What I'm going to do is I'm going to set up all the units correctly, and then I'm going to do the numbers. Just because it's nice to only think about one thing at a time. Here, my goal is to just cancel the previous unit. So I'm going to turn miles into kilometers. Then I'm going to turn kilometers into meters, canceling out the previous unit. Then I'm going to turn meters into centimeters, canceling out the previous unit. And then my answer should be in centimeters. Now that we've done all the units, we just run the numbers, right? So I'm just going to enter them as I see them. So 1 mile is 1.609 kilometers. 1 kilometer is 10 to the 3 meters. And then 1 centimeter is 10 to the minus 2 meters, right there. Now I've got all that. We'll punch it in the calculator. You should get 2590490 centimeters. And then the last step is just how many sig figs. So this is 3 sig figs. This is 4 sig figs. These are exact, and these are exact. It's all multiplication and division, so the lowest one of those is 3 sig figs, so I would keep these 3. And I would report my answer as, I gotta put it over here, unfortunately, 259,000, or 259 times 10 to the 36 centimeters. So 2.59 million centimeters is how many centimeters I travel to work every day. I mean, when I was driving. Now I travel about, I don't know, 700 centimeters. That's how far it is from my bed to my office. So, although I do go to the kitchen first and then shower, and so I am traveling a little bit within my apartment, but it's nowhere near the same length. Working at home can be kind of nice. All right, that's simple dimensional analysis. How's the commute? It's great. I roll over out of bed and then go straight to the office. Excuse me. That's simple dimensional analysis. So when we come back on... Oops, I'm not even on the right slide here. What we're going to do is we're going to continue this section on Tuesday and then finish off the chapter. We're going to do more complex conversions, such as something like this. So if something moves 750 meters per second, what would its speed be in miles per hour? So you can convert the meters part to miles, and you can convert the seconds part to hours, but can you do them both at the same time? You can, and that's the point. So as you're doing practice exercises this weekend from the worksheets and the online stuff, be looking at problems like these in the next few slides, because this is slide... What slide is this? Where is the... There it is, okay. So this is slide 19. And we're going to do these exercises on Tuesday next week. It doesn't apply to this class, but Monday, I believe, is a holiday. I believe it's Martin Luther King Jr. Day. So just a heads up. But that is all that we're going to do today, because I only have 7 more minutes left. So that's the end of lecture. So let's put this guy up there. We'll do the standard, thank you for coming to lecture. Thank you for coming to lecture. Maya is very happy to see all of you. She just knows when I am teaching because I'm talking to somebody, and I don't really talk the rest of the day unless it's to them being my cats. Maybe that's what it is. Maybe my cats just think, oh, Wes is talking. We should go be there for him. Otherwise he will go crazy. Have a wonderful weekend. Make sure that you're doing the practice problems. The quiz for Units 1 and 2 will appear shortly. I'm going to go put it up online. In a little bit, I'm going to start recording the lab lecture. I will have the chat turned off for that, so you won't be able to communicate with me, because the point is just, I'm going to give this and you will watch it later, presumably. But send me any emails if you'd like. Send me questions in Discord. Make sure you jump in that if you are looking to get people to work together on problems or a group. And stay healthy, stay safe, and stay home. Have a good one, and I'll see you next week.